Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ogwabela Wemets. And without any further ado, let's look at these questions that we have here. Ah, okay, so we have question 6 on Doppler effect. It says the siren of a stationary police car emits sound waves of wavelength 0.24 meters. The stationary listener now hears a sound with a frequency of 50 hertz higher than the sound emitted by the siren. Right. Then assume that the speed of sound in air is 340 meters per second. Now 6.1 says state the Doppler effect in words. Right, so Doppler effect, we are going to say it is the change in frequency of the sound detected by the listener because the sound source and the listener have different velocities. Relative to the medium of sound propagation. Relative to the medium of sound propagation. So that's it. The change in frequency of the sound detected by the listener, because the sound source and the listener have different velocities relative to the medium of sound propagation. And that's how you have it. Right, so for 2 marks, you are supposed to define it exactly like that. Then 6.2 says calculate the frequency of the sound emitted by the siren. And once again, we have a 3-mark question, which we do know that this is just formula, substitution, and the correct answer. So the formula that we are supposed to use is V is equals to F times lambda, where our V here is for the speed of sound in air, which is 340. So note here, the V that we are using there is for the speed of sound in air. Then the frequency, we are not given the frequency, that's what we are looking for, but we do have the wavelength, it's 0.24. Now, if we divide both sides by 0.24, then our frequency becomes what? It's 1416.67 hertz, right? And there we go, 3 marks. Then 6.3 says the police car moves a distance of x in 15 seconds. Calculate the distance x. So now we are told that the police car is moving, right? And then now the stationary listener now hears a sound with a frequency of 50 hertz higher than the sound emitted by the siren. So note that. So he's hearing a frequency that is 50 hertz higher than. Now we have calculated the frequency of the source, and then we found that it was 1416.67 hertz. So if the frequency being heard by the listener is 50 hertz higher, that means it's just 1416.67 plus 50. Right, so that's what it means. And then we are supposed to get 1466.67 hertz. So that's all that you needed to first consider. We do have the frequency of the listener in the fact that we will take the frequency of the source and add it with the 50 hertz there. Okay, so now we have frequency of the listener is equals to V plus minus VL over V plus minus Vs times Fs. And then since now the frequency of the listener is greater than the frequency of the source, we know that this means that the police car was moving towards the stationary listener. So that means our arrow has to point upward there. So this indicates that our positive will be up here and then our negative down here, right? Positive on the numerator and negative on the denominator. Frequency of the listener is 1466.67 hertz. And then velocity, speed of sound in air, meant to say, it's 340. And then we have our plus. Velocity of the listener is 0 because we are told that the listener is stationary. Now 340, we must calculate the velocity of the police car since we are told that the police car is moving. And then frequency of the source is 1416.67. This point, when we want to calculate, we know what to do. We can just cross multiply here. So basically, when it comes to this point here, it's just your maths muscles working, right? And then you need to multiply that 1416.67, multiply it by 340. You are going to get 481,667.8, right? And then here we must multiply inside like this. And then so we have 1466.67 multiplied by 340. Or we can just simply do this. Before we just multiply inside, let's just divide both sides by this to make things easier for us. So this is a much more fine approach. So we have the 4,801, 667.8. Remember, at this point, you can just do everything on your calculator, and then simply just come up with your final answer, right? So 328.409. And then now when I want to calculate my VS, I have to take this one over to that side. So this will be 340 minus 328.409 is equals to VS. Now, therefore, my VS will be what? This will give us 11.59, rounded off to 2 decimal places, meters per second, right? So now we do have the velocity of the police car, but then we are told to calculate the distance. Now we do know that if we have the velocity is simply the rate of change in position, right? The rate of change in position. So that means velocity is just simply delta x over time. So now we'll say v is equals to delta x over time. Our delta x representing the distance. And then, okay, our delta t, we are given that it is x seconds. So it covers a distance x in 15 seconds. Then our velocity 11.59. We are looking for delta x, but then our delta t is 15. So if we cross multiply these ones, our delta x will be equals to what? So this is 11.59 multiplied by 15 is going to give us 173.85 meters. And there we go. Just like that, easy peasy. So that's how you could have calculated your 6 marks there. So unfortunately, it was not a simultaneous equation, but then you had to actually find something first before you can get to the one that you are looking for. So I did mention that a 6-mark question can either be a simultaneous equation, a type of question, or it can be a question whereby you are looking for this particular value, but then before you get there, you need to solve something first. Just like in this case, we had to first figure out what is the velocity of the source, what is the velocity of the police car. Then from finding the velocity of the police car, that's when we can then find the distance that we are required to calculate, right? So understand the nature of a 6-mark question when it comes to Doppler effect. You usually have 2 unknown variables. Okay, then 6.4 says, state one application of Doppler effect in medicine. So we know it is used in the Doppler flow meter. And then others can say it is used in sonar. Okay, so let's just write for the Doppler flow meter to detect the heartbeat of a fetus. And then that's it, guys. That's how you were supposed to go about answering this question for a total of 12 marks. And then you know what to do. If you've enjoyed the lesson and then you found it helpful, please press the thumbs up button. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.